Hey guys, Megan from the Kansas Aviation Museum here again. Today I'm here to show you something kind of fun. It's an experiment that everybody can do at home. All you're going to need is an empty water bottle and a balloon. And this goes very well with the book we are going to read called Sally's Great Balloon Adventure. So what kind of experiment are we going to do today? We are going to learn how hot air balloons fly. So we're going to make kind of our own. This one won't fly, but it'll show you how it works. So again, you need a balloon and a water bottle, and I have two things of water here. This one is my hot water, this one is my cool water. This one be careful with, because if you get it too hot it can burn you. And this one was just cold ice water. So what you're going to do is take your empty bottle, take your balloon, and very carefully put your balloon over the top of your water bottle. So make sure it's a tight seal. With my air temperature being about 70 degrees here, I have a little density in the air. It's not too warm yet. But what I'm going to do is I'm going to hypothesize or make a guess that when I put this in the hot water, the empty water bottle, my balloon will expand even more. Let's see what happens. And again, be very careful to not touch the water if it's too hot. Okay, mine is pretty, the balloon is pretty inflated here. I mean, it won't inflate fully, but for all intents and purposes, my balloon is inflated here. When I pull it back out to room temperature, it should deflate a little bit. And I can see it already starting to deflate. I'm not going to touch it, and it will fall over eventually because it's not going to have enough air to hold it up. And it's starting to kind of deflate. But when I put it in the cold water, you will see almost an immediate reaction. And you see the balloon completely deflate, and I don't know if you can see it, it's actually contracting and pulling the balloon itself almost to the state it had when it wasn't even blowing up. So again, there's no inflation within that balloon. So I pull it out, air temperature, the air gets a little bit less dense, therefore causing a little bit more expansion. Then I'm going to put it in my hot water again, and you're going to see it inflate pretty quickly. The reason this is happening is warm air, as I'm warming the water bottle up, again there's nothing but air in it, as I'm warming that up, the air becomes less dense, meaning that the air molecules actually fly away from each other. Whereas with the cold water, it becomes more dense, meaning more compact. Those air molecules are staying tighter together. So with what air molecules do, they will always be moving, but they're going to be in a much tighter area, so therefore not expanding out. So think of it as a small classroom. Everybody is put in together. It's a pretty dense classroom. There's a lot of people next to you and close to you, so in a smaller area. But as we take our water bottle out, it's like moving the class outside recess on the playground. They all run around, they all go different directions. It becomes a less dense area. Well, how does that affect airplanes? It affects it in three different ways. First of all, lifting force decreases because there is less air. Remember when we had talked about Newton, with every action there's an equal and opposite reaction, so the air actually pushing it up to create that lift, there is less of that air there, so it will take a longer runway for airplanes to take off. And there's a couple other factors we have to consider with that too, such as altitude and humidity, but we're not going to get into that today. All you need to know is that the more dense the air is, the better the airplane can fly. So that's why it performs better in cooler weather. Second thing that low density does is it decreases the engine's power because, again, less air to create that combustion, that reaction to create the power in the engine. And the third thing is the thrust. So what creates the thrust? The propellers, or the propellers on the top of a helicopter. It literally has less air to grab onto to create that thrust. And with hot air balloons, it works very similar to this. If there is heat underneath the balloon will expand. And the way the pilots control that is there's a fire underneath the giant balloon in something called a gondola, and they either increase or decrease the intensity of that, or they can vent out the air at the top of the balloon, which will then adjust their altitude. So that is how hot air balloons work. And be sure to check out the video of me reading Sally's Great Balloon Adventure. See y'all later. Thanks, guys. Bye.